Good evening. Welcome again to our Londroid event. My name is Jiri Bruchanov. I work here at Lloyd's as an Android developer. I do Android development approximately for 10 years. And today I'd like to introduce a tool what I built a few years ago. I call it simply UI Tour, which is a shortcut for a user interface inspector, which was the initial idea. Today, with additional more features, it's more like an Android app inspector. So what is the UI Tour? It's basically a layout inspector. You can get all the details about your view hierarchy, about your views you have on a screen, and it's something also what I call a components inspector. So you can get more details about actual running activity and anything what lives in the activity itself. So for example, fragment arguments, intent, and anything what is related to those two main components. In general, it's a tool which is trying to help you be a little bit more efficient in terms of UI debugging, and I use it a lot whenever I join a new unknown project because it helps me kind of to get better understanding about the structure of the view hierarchy, because I can see immediately what the activity is on screen, what the fragment is what the fragment is active, and any kind of view details like view ID and properties. What does it do? Basically, it takes a snapshot of your current running context from two different point of views. The first one is the view hierarchy. Second one is the component hierarchy. It renders these data in multiple ways to let you understand better what's going on a screen. There is also an inspector for application resources. There is also a file browser and small IDE where you can execute your custom code. How does it do it? Basically, the app is split in two main parts. The first one is a web service running in the application. So you have to have a base code basically to start the service in it. And the second one is the UI Tour web client, which takes the data from the data source and renders them in a few different ways. The UI Tour has predefined multiple extractors, which are basically classes which takes instances of, let's say, views or activities. It gets the data, public properties, and transfer them into something what might be useful for you. So for example, let's say a view's visibility. It's an integer, but it's not that easy to understand just a value. So it takes the value and translates it into visible, invisible, or go on with something what is more human readable. First part is the layout inspecting. There are three main screens. The first one is the 2D preview, which is basically something similar to what we have now in the Android Studio. There is a 3D preview, which was basically inspired on the Xcode inspector I saw a few years ago, and it's something similar what Google is now building in Android Studio 4. And last but not least is a tree view, where you can get easily like a tree graph of your view hierarchy to kind of get easily understanding how big it is and analyze that if it's too wide or too deep, and potentially find a like easy spot for any kind of improvements in terms of the view hierarchy. Each of those main screens, there is like a detail for view properties. So anything what is public, you can see all those details, and potentially, for example, in image view, it has a drawable, so you can get even details for those drawables and I don't know, layout params and anything what might be interesting for you. So let's have a look. First example. Is it working? Yes. So as you can see, this is a sample app. If you start the UI to service, basically you'll get a notification here with the IP address and the port it's running on, and if you open it, you'll get this main screen. Hopefully it's visible. Yes. So at the top you can select your running activities and a few buttons to open the particular inspecting screen. So if you open the layout inspector, as you can see, it's a preview which is showing something different, unfortunately. So you can get details about the drawable itself. There's a small preview. You can see anything you might be interested in, bounds, alpha, any flags. Similarly, for example, there is an image button. Again, all potentially important properties you want to see. Background, and again, let's say a drawable. If you want to open it, as you can see, it's a bitmap drawable. You can immediately get details about the bitmap, color space, how much memory does it need, intrinsic size, bounds, anything you might like. Those two previews, they have dedicated extractors, but there is one specific for objects which are kind of hard to extract. So I'm using a reflective extractor. So for example, in a case you have a recycle view. Again, if you open that, it's here, and you can even get details about the adapter. By itself, it doesn't show here much, but there's a raw JSON button. So if you open that, you can get all the extracted data as a JSON. So you might find anything you like. And as you can see, in my case, for example, get item count is 30, and I have a private field, which is just a string array of those three elements, which I'm using as a data source. For the 3D inspector, if you were ever wondering, for example, what is going on with the scroll view and the views outside the visible range of your display, you can just do basically put the app to the state you want, and if you load it, you can see, hopefully, you can see full view hierarchy, and if you ever were interested in how the app looks like from the back side, you can just do that, and you can do whatever you want. On the other hand, if you want to ensure that recycle view is different to scroll view, it's basically same screen, just implementing using recycle view. Again, opening the 3D inspector. You can see that the recycle view, it's using just a minimum amount of views to fill the designated area to the recycle view. So hopefully it's visible or not. Yes. When I select the view, you can select anything in the view hierarchy and get the details again. So for example, this text view, and if you want to see, for example, a layout params, you can get those again. And because it has designated, again, an extractor specifically for relative layout params, you can see, for example, here, all those three rules I applied for that particular relative layout of that view. Last but not least, the view hierarchy, which is that tree. Let me open just a little bit more simple screen. It's still big enough, but anyway, this is a tree. There are three ways of rendering. This is the default one, when you can see a type and a view ID. Short type is a little bit more condensed, but it's using just capital letters of the type, and the simple one is just a simple, just about the view nodes. So let's have a look at a real app example. If you don't know the Android app we are building, this is basically a main screen for arrangements, when you can see all the transactions you made. Scrolling up, down, you see more of those transactions. Swiping left and right, you are changing a month. So first side, the screen itself doesn't seem to be too complicated. If you take a look at this middle part, for a tree view, you can see a lot of views, which is a little bit suspicious. So if you open this tab for stats, you can immediately see that it's something kind of suspicious because we have 437 views on a screen. So if you take a look in this, basically a type of view and amount of that screen. So for example, this case, 180 text views, 41 relative layouts, 91 views, or 9 recycle views. So like you can see, these numbers are quite high. So to get better understanding, if you take a look at 3D Inspector, it will give you immediately the hint what's going on here on this screen. And back to the tree view, if you open that in a simple, you can see it's massive and it's a super wide. So whenever you find that this node, which is getting details, oh, you see it's a view pager, so whatever is happening there, the view pager is set to have a lot of preloaded screens. So if you want to, like, you can easily see this is kind of like an easy spot place what you might be trying to think about, like improvement in terms of a view hierarchy. Another example, same app, different screen. This is a payment screen. If you open the stats, as you can see, 141 views. It's not that bad. One kind of a little bit suspicious, there are 22 linear layouts on the screen. So opening a 3D Inspector doesn't help much in this case, but going back to the tree view, you can see it's not that bad, but these two parts, they are kind of deep and they are identical. So immediately you can easily spot again, place what you might to try to improve in terms of view hierarchy. That would be first part of demo. Let's go back to the presentation. Yes, second part is the components inspector. As I said earlier, one part is the UI component, so anything like activities or fragments you have on a screen or on a backstack, you can get details about those. There is also a resources browser, so you can get any resource, almost all the resources predefined for your app in a context of your running application. That means if you have, for example, different assets for different densities, you'll get the one which is designed, or which is supposed to be for your device. Or if you have a qualifier for like a portrait or landscape, you'll get the one where is the device state in. There's also a file browser, so you can easily see how the app sandbox looks like. And if you have a permissions, you can of course take a look how the SD card looks like. So let's take a look at another example. So the resources browser, let me just open the small agenda to know what I want to show. As you can see, groups of resources types from your app and from Android. So if you want to see, for example, a color, there are many of those, and there is this sample list, so you can get easily like a value ID, which is not that important, but you'll get an XML preview and all those defined states easily on one screen to see. Similarly, if you want to, for example, animation drawable, as you can see, small, predefined, just 3 frames as a sample, but you can see all of those frame defined in this screen as well. Similar, just a XML drawable, same thing, XML, all those previews. If you are interested about the font example, you can see that as well. The image is rendered on a device and then the client is just showing it. And one last amazing effort what Google did, if you remember, I believe it's from Android 1, there's a rating bar view or something like that, which I never seen to be used in a real app. But it is using an asset which has many styles predefined. So as you can see, they made like 12 states or something, which is amazing piece of work, because like usual app is like 3-4 states at maximum, nothing more. So this is like really amazing work that they did. The file browser, as I said, you can easily go through. I don't have SD card permission enabled, but there's not much to see. But in a sandbox, for example, if you are interested in how the shared preferences looks like, you can go there, open it, and then, as you can see, it's just a simple XML file. So if you want to see that, you can. Same way, like for example, the UI to our web page, I do have it in here in a cache. So there's a, for example, a loader GIF. You'll get that file. And you can preview that, or if your app is using Sandbox, for example, for SQLite, you can just easily get it and use it in some better tool. Last but not least, the Windows and Windows detail, which is about the UI components inspecting. As you can see, this is like a simple tree-like table. At MoiStay, there's a simple application as a root and one running activity with 3 fragments. That's not that interesting. If I open another activity with a child fragments and reload it, you can immediately see I have 2 activities on a backstack, and this another activity has a child fragments with another child fragment, so you can immediately see what is on the screen and how the UI is structured. Windows details is the same data source, again using just or presenting just a JSON. So if you want to see, for example, intent for your activity, this is the another activity and this is the intent, so you can see no action, no categories. This is the component that was used. And for example, I just made this example for argument in a bundle and in the intent. So if you want to see, you can flags, same thing, support fragment manager. You can see all the details about the fragments. For example, the ID, what I'm using, and anything you might be interested in, you should be able to find it here. Let's go back to presentation. Last part is kind of like a code execution environment. Oh yeah, sorry. Code execution environment, which is a small web IDE where you can type kind of any groovy code. Then it gets sent to the app, gets compiled and executed in the context in your process. You can get any reference to your activities, to fragments or views, anything you have, and you can use it. So let's take a look. Another example for the code execution. So as you can see, this is the Groovy IDE. There are a few predefined variables as a root view or app or activities. So let's say, let's make it a little bit simpler. So in my case, this is just an activity, and this sliding menu, it's a slate pane. So there is in my activity, there is a field which is named mpane layout, and because it's private, I'm just accessing through the, like using in a reflection, and it's just doing the same thing, simple thing. If it's open, it gets closed, otherwise it's get open. So if you execute that, you can see immediately it executes that code. If you want to play a little bit more, let's say about with view, if you, for example, open the layout inspector, if you pick your view here, there is a link for a Groovy console. So as you can see, it has predefined a variable here. So you can start playing with that. So if you wanted to do anything like changing a background, for example. You can do that. You can easily do any a little bit more crazy stuff, just like starting a thread or do anything you might want. As you can see, it's just thread is started, it's changing a text, it's changing a background, whatever you basically write in the Groovy, it works. In terms of other platforms, because the web client, it's just a simple web application, you can build your own web service on iOS or any other platform, which is the only thing is basically providing a same structure of the data set and you can use it. In terms of the view hierarchy, each node has approximately like 10 mandatory fields like view ID, something about the visibility, about the location, to be able to just identify it on the screen and find it. And I built quickly iOS simple example so we can take a look. It doesn't extract any specific data, it just builds the view hierarchy to kind of have something presentable. And as you can see, it works easily. One kind of interesting point or interesting thing for me is just how slightly differently the iOS view hierarchy is defined. So for example, this UI stepper, as you can see, like in Android, it would be easy to build like one custom view, or just quickly you can do like 2 buttons in a linear layout. And iOS, this is a default UI view. So as you can see, it's using a lot of UI views in it, just basically to any like a rendering component, its own UI view. Similarly for this slider, as you can see, that it has like 1, 2, 3, 4, 5, 6. And the main one, like a 7 views for something what we have as a one single view on an Android. So as you can see, it's not hard to build it. You have to just provide some. You have to just build a web service and provide some kind of data set. I'm not sure how much time do we have. Is it enough? 5 minutes? In terms of customizations, as I mentioned earlier, there are many predefined extractors for types like views, activities. You can, of course, define own extractor as well. If you have, for example, MVP in your app and you have like a relation that the fragment has a presenter, you can easily write an extractor for your type of presenter and get the details. Extractor for your fragment and get the details about your presenter. There are few configurations for the client, for example, like a type highlighting if you are interested about specific type, like a button or something like that, or if you want to change that, the pointing cursor, you can change the color if you had a super red app, which wouldn't work in my example. There are a few limitations because every time I take a screenshot of that view, it's happening on a software layer. So whenever you have something what is happening on the hardware layer or in the OpenGL pipeline, you won't be able to see that. So for example, no shadows. If you have a view elevation or if you have a card view, the shadows won't be there. Same thing if you have a special view like a surface or video view, you will get all the details, but the content won't be visible. Currently, I don't have support for the storage access framework, so if you have an app which is targeting Android 10 and it's running on Android 10, you won't be able to explore the SD card. There is no explicit accessibility support, so whatever is on a view, let's say content description, you'll get it. But if you build a custom view hierarchy for the accessibility, it will be just ignored because there's no support, as I mentioned. And the Groovy compiler, it's it's working only on the API 26 because there's some internal dependency on Java 1.8. In terms of implementation, the Android service, it's using a Ktor, specifically with Netty Engine, simple web server, Apache Groovy compiler, which generates a jar file, then using jar 2dex from Google to convert the jar 2dex format, so you can load it and execute it in the app. As I mentioned earlier, those extractors, simple classes, it takes instance of a view or activity and gets the data into like a data set which is provided to the client. For the web client, it's written now in a Kotlin. I recently rewrote everything from Google Web Toolkit to Kotlin, so I am pretty sure there will be a lot of new bugs and excitement stuff. For tree generation library, it's a D3, which generates just SVG. And for the WebGL or the 3D preview, which is using WebGL, it's a 3JS library. So that would be kind of all. 3 main links, ui.scrub.com. You can see details. You can see like a snippet for code, how to add a dependency, how to start the service, 2 repos on a GitHub. Everything is open source, so please take a look, try it. I'm pretty sure there will be a lot of bugs, so any feedback would be highly appreciated. And yeah, that would be all. Thank you for listening.
Would you mind answering the questions in this one?
Yeah, definitely. And I forgot now, it's time for questions. Yep.
I know this is quite a simple question. What do you need to do in your Android app, or do you need to do anything to actually be able to access this?
In the app, like it's basically a simple dependency as any other library, and basically, this is the only thing what you have to do, start service. And if you have like a non-trivial project set up, you have to just pass your R class to load it. But everything else, the service takes care about. So internally, if you were interested, where I get the references for activities, in the hidden API, there's a class called the activity thread, I believe, which is a singleton basically. So I'm just now using a reflection to get those, which works for now, but I'm not sure like if Google makes that like blocked or the black API, I'll have to probably figure out another way. But currently, that's like the entry point. I take the activities, and whenever you get the activity, you have access basically to anything.
Actually, I wanted to ask if you could tell us a bit about the extractors, just very briefly.
Yes. Currently, I do have this JSON file. Those are basically extractors I have defined. So you can see many views and many components here, which is just JSON with names of methods to call. So as you can see, like this is an API 1 and all the methods what I'm interested about. And in the compile time, I have a script which generates classes. So the extractor itself looks like that. So whenever I go through the view hierarchy, I'll try to find the most specific type of extractor based on the view type or any kind of class type, and pass it in. And as you can see, it just basically calls the method itself and saves the data into the map, which is then serialized into JSON.
Thank you. If there's no more questions, then I think that anyone with the courage to do a live demo deserves an extra loud round of applause.